Let's take a look at the questions at the end of the tangent lines video. So we've got the first one says an equation of the line tangent to the graph of y equals x times 2 minus x cubed at the point 1, 1 is. Now, before we can apply the power rule, we've got to multiply this out right here, okay? We cannot apply the power rule without multiplying this out. So let's figure this out. We've got to do 2 minus x times 2 minus x times 2 minus x, okay, and then multiply that all by x. So let's just start by pairing them up, okay? 2 minus x times 2 minus x, I'm going to run out of room here if I'm not careful, is 4 minus, let's see here, we've got minus 2x, so minus 4x, plus x squared. Be careful with those signs. Okay, let's go ahead and distribute the x here. So we've got 2x minus x squared. Now we only distribute it into one set of these parentheses. Okay, do not distribute it into both, or you're really distributing x squared, not just x. So let's distribute here. Distribute the 2x to everything. So that's 8x minus 8x squared plus 2x cubed. And I'm going to do the next part on the next row, minus 4x squared plus 4x cubed minus x to the fourth. So now we've simplified the function. Now we can take the derivative, y prime. The derivative of 8x is 8. Let's combine like terms right here. So we've got negative 12x squared. So when we take that derivative, that's negative 24x. We've got plus 6x cubed. So when we take that derivative, plus 18x squared minus 4x cubed. Now we can plug in 1. So we can plug in 1 for x. So we've got 8 minus 24 plus 18 minus 4 when we plug in 1. So 8 minus 24 is negative 16. Negative 16 plus 18 is 2. 2 minus 4 is negative 2. So we can eliminate, because they don't have the right slopes. And then they did put it in slope-intercept form, so we do need to simplify this. Y minus 1 equals negative 2 times x minus 1. So we've got y equals negative 2x plus 2 plus 1. So plus 3. So this should be our third option right here. Okay, let's look at this next question, which I did not cover in my lectures. It's coming up, but you should have heard Kim talking about it if you actually watched the video. So let's look through this. It says, suppose f of 6 equals 3 and f prime of 6 equals negative 2. Using a linear approximation, the value of 6.2 is best estimated. What we're doing is we're writing the equation of a tangent line here. Y minus 3 equals, the slope comes from the derivative, so the slope is negative 2 times x minus our x value of 6. So we've written the equation of a tangent line. We can use that to approximate for 6.2 because 6.2 is really close to this. So let's do that. I'm doing this with, it says you can use a calculator, but I've seen them do these as non-calculator problems because they don't, I mean, they give you something that's really close, and really it's easiest if you leave it in this form because 6.2 minus 6 is 0.2. So negative 2 times 0.2 is negative 0.4, and we add 3 to that. So 3 plus negative 0.4 is 2.6. 2.6. And just as an FYI, notice how all these answer choices are very close to 3 because our x values are close, so our y values should be pretty close. Okay, let's look at the last problem. Same thing. Okay, they just don't give us the derivative at a point. They give us the equation for the derivative, but we know that if we have the equation for the derivative, we can find the slope of the tangent line. So f prime of 2 is 2 squared plus 1 over 2 minus 1. 2 squared plus 1 is 5. 2 minus 1 is 1. So f prime of 2 equals 5. So that's the slope. So y plus 4 is equal to 5 times x minus 2. Okay, and then we're approximating for 2.1, so we've got y plus 4 is equal to 5 times 2.1 minus 2, that's 0.1. So we've got y plus 4 is equal to 0.5 when we multiply 5 times 0.1. So when we subtract 4 from that, we get a negative 0.35. So let's check and make sure I didn't do anything silly. And that one's right, and the last one is right. If you got questions, let me know.